Hello classmates, today we will learn about the formulation of the process route. Firstly, let's learn about the selection of surface processing methods of mold parts. The selection of surface processing methods is to choose a reasonable set of processing methods for each surface with the quality requirements on the part. When choosing the processing method, the final processing method is generally selected based on the surface accuracy and surface roughness requirements, and then the processing methods of the series of preparatory processes before the process are selected, and the order before and after is listed. After one processing, the precision requirements specified in the design drawing are achieved. The machining method for the outer surface of parts mainly adopts the following four basic routes, as shown in the figure. Firstly, rough turning, semi-precision turning. Precision turning is the most widely used machining route, which is suitable for the machining of non-quenched parts. Secondly, rough turning, semi-precision turning, rough grinding, precision grinding, mainly used for quenched steel, not suitable for processing non-ferrous metals. Thirdly, coarse turning, semi-precision turning, precision turning, and diamond turning are mainly used for precision machining of non-ferrous metals. Fourthly, coarse turning, semi-precision turning, rough grinding, precision grinding, and grinding are mainly used for processing that requires high quality. The machining scheme for the outer surface is shown in the table below. We can choose the corresponding machining scheme based on the dimensional tolerance and surface roughness of the outer surface. The machining process route for each house mainly adopts the following basic machining rules, as shown in the figure: drilling expansion hinge, which is mostly used in unquenched situations. Second, drilling rough boring, semi-precision boring, precision boring, or diamond boring applied to the machining of large diameter holes in box house, or precision machining of non-ferrous metals. Third, drills or rough boring, semi-precision boring, rough grinding, precision grinding are mainly used for processing quenched steel or holes with high precision requirements. Fourth, drilling, rough drawing, fine drawing is commonly used for the processing of circular holes, spline holes, and other parts in large-scale production of discs and slips. Its processing quality is stable and production efficiency is high. The selection of hole processing plane is shown in the table below, and the processing plane should be chosen according to specific requirements. The flat processing plane is shown in the table below. Select the corresponding machining plane based on the dimensional tolerance and surface roughness value of the plane. Second, considerations for processing methods. The selection of processing methods should not only ensure the surface quality of the part and strive for high production efficiency, but also consider the following factors. First, economic accuracy. Economic accuracy refers to the processing accuracy and surface roughness that can be guaranteed by a processing method under normal processing conditions, using standard equipment and technical level workers without extending the processing time. The lower the processing error of any processing method, the higher the processing cost. However, even if the processing error of the finished product is increased, it is not easy to reduce. Conversely, when the processing error is large enough to a certain extent, the cost will not decrease. Economic accuracy is the processing accuracy between the above two situations. Second, structure, shape, and size. Taking hole machining as an example, small holes require reaming. Larger holes require boring, non-through holes require pulling, and difficult to grind. Small holes require grinding. Third, for the material and heat treatment requirements of the parts, the surface material after quenching is processed by grinding, while the surface that requires precision fitting before quenching is scrubbed and ground using machine tool guide rails for non-ferrous metal materials. High-speed precision machining, precision boring, and precision milling are used to avoid grinding while clogging. Fourth, productivity and economy. Considering the production efficiency and economy of parts, milling can be used for large flat surfaces. Planing can be used for narrow and non-flat surfaces, and CNC machining or electrical machining can be used for curved surfaces. Third, division of processing stages of mold parts. Next, we will learn about the division of the machining stages for mold parts. The machining process can generally be divided into the following stages. First, the rough machining stage, whose main task is to efficiently remove the excess amount on each surface to make the blank close to the finished product in shape and size. Second, the semi-precision machining stage, whose main task is to eliminate the errors left by rough machining, achieve a certain level of accuracy, and leave a margin for precision machining, preparing for the precision machining of the main surface and completing the machining of some secondary surfaces, such as drilling. Third, in the precision machining stage, the main task is to remove the small amount of excess left by semi-precision machining, ensuring that the main surfaces of the parts meet the quality requirements specified in the drawing. Fourth, during the finishing stage, parts with particularly high precision and surface roughness requirements need to be processed using finishing. The general principle of arranging the cutting process is that the preliminary process must create conditions for subsequent processes to prepare the benchmark. The specific principles are as follows. First, the principle of reference. First, the surface used as a fine reference should be prioritized, because the more accurate the surface of the positioning reference, the smaller the clamping error. Second, the principle of rough first and then fine. The processing sequence of each surface is carried out in sequence according to the order of rough machining, semi-finishing, precision machining to gradually improve the processing accuracy of the surface and reduce the surface roughness. Third, the principle of primary and secondary. The main surface of the part should be machined first to detect the possible defects on the main surface of the blank as soon as possible. Fourth, the principle of near and far. First, the part close to the tool holder after the workpiece is clamped, and the part far from the tool holder is processed later, which can shorten the distance of tool movement and reduce the empty travel time. Fourth, centralized and dispersed processes. After selecting the processing steps for each surface and dividing the processing stages, when formulating the process route, the various processing surfaces in the same stage can be combined into several processes. The division of processes follows two principles: centralized and decentralized processes. Process concentration refers to the process of concentrating the processing of workpiece in a few steps with a large amount of processing content in each step. Its advantages are, firstly, the use of high-efficiency specialized equipment and process equipment for high production efficiency. Second, reducing the number of clamping times, ensuring the relative positional accuracy between surfaces, and shortening the auxiliary time. Third, reducing the number of processes, machine tools, operators, and the production area can save manpower and material resources, as well as simplify production planning and organizational work. The disadvantage is that the centralized process usually requires the use of specialized equipment and process equipment with high investment, difficult adjustment, and maintenance of equipment and process equipment, large production preparation workload, and troublesome conversion of new products. Process dispersion refers to the process of dispersing the processing of workpieces into multiple processes with minimal processing content in each process, and sometimes only one step per process. The advantage of dispersed process is that the equipment and process equipment are simple, easy to adjust, and easy for workers to master. It is also easy to adapt to product changes, and the most reasonable cutting parameters can be used to reduce processing time. The disadvantage is that there are a large number of equipment and process devices, a large number of workers, and a large production area.